Hi everyone, my name is Aida Yanumunga. I'm a graduate student at Morgan State University and I'm a student at the School of Engineering. My major is civil engineering, and for this project I work with Dr. Kosi and Dr. Peng as advisor, and we work for the chemistry department. The title of our presentation is Adapting an Experiment-Centric Teaching Approach to Increase Student Achievement in Chemistry. We'll first of all try to define what is experiment-centric teaching approach. It's a teaching technique that utilizes hands-on activity through an inexpensive, safe, and portable electronic instrumentation system that can be used in classroom and student laboratory to teach some of the STEM concepts. And to do that, active learning is the approach that is chosen. We go through assessment, presentation, investigation, simulation, and practical steps for the student. Most of the students are asked after the class to connect their learning to real life situation, to learn outside the classroom, and to promote teamwork and group study. In fact, the use of electronic devices such as analog devices in chemistry curricula have increased these past years and results are good concerning student interest and motivation. For example, students at the University of Wisconsin were asked to construct a fully operational photometer for their experiment coupled with a microcontroller interface using a simple circuit component with the main aim to use it to measure the concentration of exact volume chromium. Most of the students found it easy and very interesting. Another study performed at Texas Tech University investigated the development of an inexpensive device useful to dispense exact volume of fluid using an electronic burette, which is an useful tool for the titration in chemistry laboratory. Results presented by this study shows that students found the reading of the voltage that was more interesting compared to estimating a burette reading. The overall score of 4.1 on 5-point scale obtained from the student on survey shows that the device possesses a remarkable potential on use of electronic device to teach STEM concepts. The main aim of this study is to promote a precise observation which relates to motivation and interest from the student and the explanation of results observed. Besides, I also asked to relate their learning outcome to real life situation. So for this case study, we use a sensor probe which is connected to a board. For our case, we use the ADLM 1000 and the data is processing through the senior console conditioning, AD converter, processor, and display the unit we like the as degree Celsius, pH, temperature. These are all the units we can have. So for this spring 2021, 42 students were involved in the experiment and 2 faculty members were involved. The pH implementation done by Dr. Kosi was for 18 students, and the second one, which is the thermochemistry, was demonstrated by Dr. Peng, and 24 students were present in the classroom. 2 labs were developed. The first one was potentiometry. We have acid and base concept, and the second was the thermochemistry. Here we have to teach the exothermic and endothermic concept to students. The figure 1 show a typical example of pH scale according to some of the most common used grocery items you can find anytime at home. So the material used for the lab 1 was the board, the M1K, the sensor, and for the chemical used, we asked the students to look for water, toothpaste mixed with water, bicarbonate, soda, lemon juice. Any chemical the student may use, were able to find out when we asked them to collect it and to measure the pH. So the experiment setup is on the picture shown at the right bottom of the slide. The second experiment, we use a calcium chloride. We also use the ammonium chloride and the sodium chloride. And this picture in the middle can show the sensor AD22100, and the experiment setup is shown above the sensor. Chemistry department implement in two parts. The first one was the virtual classroom observation, as you can see in the picture, and the second one was face-to-face classroom implementation. Students during this session were asked to bring computer, and they were given all the material to carry out the experiment. Results were obtained using a evaluation method based on classroom observation protocol for undergrad STEM, which is also known as corpus, and also motivation strategy for learning questionnaire, which is also known as MLSQ. The corpus shows that student engagement for this spring 2021 shows student doing with ECP and student doing without ECP. The first pie chart shows what the students are doing with ECP and what the students are doing without ECP. You can see the difference on the two pie chart. Most of the time with ECP, students are interactive with the teacher, or in the other part, the student without ECP just listening most of the time to the lecturer. We also observed the instructor during the implementation, and we found that most of the time the instructor was trying to lecture, to ask a question, to pose a question, and to administrate the class with ECP. Without ECP, most of the time the teacher was just lecturing the class. So the second class was the implementation of the PH experiment. Here, the instructor, the student are most of the time listening, doing individual thinking, answering questions, posing questions to the instructor. As you can see, the pie chart is very colorful. Beside the other side of the pie chart, you can see most of the time the students are just listening to the instructor. So instructor during that time have a very engaging conversation with students. Most of the time he is lecturing, posing questions, answering questions, and discussing one-to-one with students. In the other part, he just lecturing and answering questions to students to make them understand, which is not really colorful, as you can see the difference on the two pie chart. So the MLSQ were evaluated based on 7-point Likert scale, from strongly disagree to totally agree. And the key construct used for this was intrinsic goal orientation, task value, expectancy component, text anxiety, critical thinking, meta connection, and peer learning. The motivated strategy result shows that most of the time the pre-test and the post-test shows different results. The post-test is under the orange color and the pre-test is under the blue color. As you can see, most of the time the post-test give higher value, as you can see on this slide. The p-value obtained for this MLSQ shows, for the p-value that are less than 0.05, shows a very significant difference. And for our case, we can observe the tax value were significant, and meta cognition for students were also significant. So we can also put aside expectancy component, which was almost equal to 0.05. This shows very significant value on the change according to MLSQ. So at the end of our implementation, posted open-ended question response were asked to students. We will try to ask them to describe their experience using analog device, and to let their topic to their curiosity challenge on something other. So most of the time the students complain about the fact that they were not familiar with circuit board, and so they needed to be walked through at the circuit implementation, the connection of the circuit. And also students most of the time didn't have a correct computer. They have to be given a window computer, because at least most of the time are not compatible with those MacBook, which are basically have a low space and they are not compatible with the Alice software. basically wrap up our presentation, and thank you. Hope to see you and answer your question during the conference. Thank you.